Next up, we'd like to look at a scenario with invasive species. So invasive species are plants or animals that are introduced into an area where they're not native. And the problem is that since they're in this area where they're not native, they don't have their normal enemies. So they can grow exponentially and actually choke out the native species. And this isn't something we want to happen. So agencies have come up with various ways to control these invasive species. There's mechanical ways, manual ways, chemical ways, and biological ways. So one of these invasive species that's actually a problem in 47 of the 48 lower states is something called the purple loosestrife. The Minnesota Department of Natural Resources has determined that for their purple loosestrife program, they like to use the biological method. So the plan of attack for biological is actually this little bug. It really loves to eat the purple loosestrife. So now the question is, where do we release this bug to help control the purple loosestrife? Especially given budget constraints. We need to target the best areas to attack this invasive species so that we get the most bang for our buck and can help control that. And this is an ongoing process because it happens every year. We have to go back and do this, this management of these invasive species. So let's take a look at how we could use GIS to help with that analysis, Harry.
Yeah, let's do that, Tim. So as Tim mentioned, the purple loosestrife is an invasive species, and this bug can help with that problem because it eats the purple loosestrife. So how can we use GIS to solve this? Well, we're going to use some spatial analysis. What we're looking at here are point observations for the purple loosestrife. If I identify one of these, what you'll see is that at this particular point, there is an estimated 10 plants. When I identify one of these other locations, you'll see that the number in this area is 500 plants. So how do we know where to release this bug at? There's just so much information here. Well, the first place I think we should start is actually with symbology. So let's look at that. So what I want to do is to symbolize this information based upon the total estimated number of plants. So that flip this so that the plants that have, or the points that have more observations will be red. Maybe that will help us understand some patterns. I still can't see patterns with that, even though the coloring has been updated. Even when I zoom in closer, it looks like there may be more red down here, but there's still some more up here, so I'm not sure. We can look at another way, using graduated symbols. And what this will do for us is the larger blue circles mean that there are more plants in that area. So let's see what happens. Again, I actually think this may be worse because I still don't know where to put release this bug at. Well, I do know the solution, and it's spatial analysis. Specifically, it's the optimized hotspot tool, which is a new tool at 10.2. So what the optimized hotspot tool does is it uses input, such as these purple loosestrife information, and it's going to give me a hotspot analysis. So the only thing I need to do is enter in the layer that I have and what field I want to run this analysis on, and that's the estimated number of plants. So I'll call this my hotspot, purple loosestrife hotspot, and hit OK. So again, we're actually looking for statistically significant clustering of this purple loosestrife. And what does that mean? We're making sure that the areas we're going to see in red, we have a high confidence level that there's clustering of large numbers of purple loosestrife. So we can see very quickly that we have these concentrations in this area, here, and down here of statistically significant clusters. So in order to help understand where to release this bug, I want to do quick selection. I'm going to select by attributes. I'm going to select where the GI bin score is greater than or equal to 2 and hit OK.
Harry,
now,
what's a GI bin?
Oh, great question. I didn't know what a GI bin was until I read the help, so I recommend reading the help. The GI bin score is just a representation of the confidence in our analysis. So a score of 2 or higher means we're really confident that there's spatial clustering going on here. In fact, it means we're 95% confident that there are a large number of plants in these areas that are now highlighted on the map. So I'm going to use the interactive selection method to remove from my currently selected area the purple loosestrife clusters on the top and the ones on the bottom. And we'll just focus right here in the main area. So now that I've identified them, I want to figure out how much area, literally land, there is around these clusters so we know how many bugs to release. In order to do that, I'm going to use the buffer tool. So under the geoprocessing menu is one of my favorite tools, the buffer tool. It's dependable for me every single time. And I'm going to look at my hotspot analysis. I'm going to make a 5-mile buffer around each one of them, and I'm going to dissolve all those buffers together, just like that. So we'll let this tool go ahead and run. One of the interesting things about the buffer tool is that you can control how the results will look. In this instance, I'm going to make one massive buffer because I've combined all of them together. But if you wanted individual circles, you could have that as well. So let's zoom in and see what we have. So here are our clusters, and you can see the areas around them. I have actually created areas that are too large. I want to reduce this purple area. So a little tip I'm going to show you guys is I can go back into the geoprocessing menu, click on the buffer tool again, and my input can be my buffer. And in this case, I'm going to say a -2 miles. And I'll dissolve them all back together. So what I'm doing is I'm using the purple area, and I'm just going to shrink it by 2 miles. So how many of you knew you could enter in a negative number into the buffer tool? All right, well now you all know that. So we'll let that run here. Ta-da! There it is. Our reduced area by -2 miles. So Tim mentioned something early on that this invasive species is something that's dealt with on a yearly basis. So to help run this analysis, what I would like to do is to make a model. So inside the catalog window, I have a toolbox for invasive species. I'm going to right-click and just add a new model. That brings up a blank canvas for me to begin to make a model. Well, instead of starting from scratch, I wanted to use the analysis I've already ran to build this model. So here in my results window, under my current session, you can see here's my optimized hotspot tool. If I just take that and drag that into the model, it will bring in not only my purple loosestrife information, but it will remember all the criteria I used to create that hotspot. I can then bring in my buffer tool and drag and drop that in there. And with just a little bit of cleanup, I can make a model that we can save and use for next year's analysis so that I do not have to start from scratch all over again. I can just open this model up and begin to run. So in this scenario, what we've showed is using the new @10.2 optimized hotspot analysis tool to understand statistically significant clusters of this purple loosestrife. The reason we want to know that is it's going to, again, help prioritize where to release this bug at. Once we found those areas, we then made buffers around them to know literally how much land is these purple loosestrifes consuming.